Hello, my name is Diego Regalado, and my project is on the Wilson Airless Gen 1 basketball made out of elastomeric polymer. Introduction. Elastomeric polymer is a type of polymer with elastic properties like rubber, and it's beneficial because it can deform under stress and go back to its original shape when stress is removed. Elastomers are widely used because of their flexibility and durability and strength. That's why they used it. They used it for making this ball so it can bounce and mimic a traditional basketball. And the background of the airless basketball is they were trying to find environmental use, a good environmental healthy use for this. So they came up with this so there's no uh, rubber, it lasts longer, no air, and the material is biodegradable. And the and it, rather than being inflated, the Airless Gen 1 basketball relies on 3D printed elastomeric polymer material and polymer lattice structure to replicate the bounce. And production. The synthesis of elastomers, they have not released the exact formula of the polymers Wilson. So I'm just guessing the polymers are uh, thermoplastic polyester elastomer or a polyurethane elastomer. Those are the two I think they mix the formula to make the ball. And so because the thermoplastic polyester helped with the environmental heating and outside temperatures, and the polyurethane helped the with it being hard and soft, and combining both of them, I think that's what they did to make the basketball. The manufacturing of the airless basketball, the process began when Wilson went to the Additives Mines Corporation and combined their stuff with engineers to make uh, the ball, of course. And using CAD software, they designed the ball, ensuring it replicates the bounce and feel of a traditional basketball while being empty and airless. The engineers, they simulated to analyze the ball's performance under different conditions. Then I think they met with General Lattice, a company making design with them so it could be read by the 3D printer. Then they sent the file to EOS, another company that manufactures the field of additive manufacturing. They used a printer called Fuse One Plus. It's a powdered printer that sweeps powder back and forth across it, while selective laser sintering sketches the pattern in 2D until going all the way up until it is 3D. The the lattice design of the pattern going up, made it for energy return and weight distribution so the ball can bounce. When the ball was finished printing, you had to dig it out of the powder from the 3D printer and then sealed it using a smoothing technique so it provide a grip. And then it's put into a dye so it changes the color, and the dye penetrates and reacts to polymer surface to change the color. They then sent it to an NBA facility so it could be go under rigorous testing to ensure it meets professional basketball standards. And that is it. And microstructure analysis, chemical structure. The chemical structure of course, we're using thermoplastic polyester elastomer because that's what I think is one of the combinations. The structure is hard and soft blocks. The hard block has a thermoplastic like polybutylene therapeutolate or a polyethylene terephthalate, which forms a rigid crystalline polyester, and the soft block is composed of a long chain polyether or polyester glycol, making it flexible. They need the hardness and the softness, and they combine those two chains. The chains of hard and soft blocks. It gives you thermoplastic polyester elastomer. That's the chemical structure of that. And the other one, elastomeric polymer, the other one is polyurethane elastomer. For the chemical formulation for that one is they just basically use disulfiram added to polyose to make polyurethane chains, and that process makes polyurethane elastomer. It's called the polyaddition or two. And the future of airless gentleman basketball, I think, will be good because it shows the future sports that's growing, and it could be included. The material could be included into equipment and gear. And I feel like if the prototype gets better in the future, we could see it being played at the highest level, like the NBA. And in the future, other types could be fully recyclable or biodegradable, so they could throw it away and it'll last longer to help the environment. And it's just a stepping stone for advanced manufacturing techniques being used in sports. And the future of elastomers is great. The demand for elastomers will rise because the versatile materials, it has both rigid and plastic flexibility rubbers, and a good chemical design. It's a balance of physical and chemical properties. Both of them mixes properties best for thermoplastic elastomers. And it's good for the environment, like I said, being recyclable and sustainable. So if you want the world to be better and be sustainable, they're looking for having the more the world wants it to be environmental, they're gonna have it, the more the material is gonna grow. And conclusion, I think the Wilson Airless Gen 1 basketball shows a good combination of materials, material science, advanced manufacturing techniques, and sports innovation. Thank you. Here are my references, and here's my face.